Lieutenant, what's the status on the alien problem?
Sir, the aliens have breached the city, and we are left defenseless.
By God, I didn't think it would come to this, but they leave me no choice. We're gonna have to go with Plan C.
Well, what's Plan C?
We're gonna nuke them.
So, sir, do I have permission to launch?
No. First we have to calculate the instantaneous velocity of the nuke as it's about to enter the alien base, to test whether it's fast enough for an explosion. We can do this by using derivatives.
The derivative can be used to find the instantaneous velocity of any object. Instantaneous velocity is the speed and direction of an object at one point.
How do we do that, sir?
Well, Lieutenant, as you can see over here, I've drawn out the graph of the path that the rockets would take from our point, right here, to point A, which is the alien space. So, how do we find out the instantaneous velocity? Well, we figured that out by finding the tangent line at point A. So what's the tangent line? Well, a tangent line is a straight line that passes through only one point of the graph. So in other words, it just grazes the graph. Whereas a secant line, like this dashed line right here, passes through 2 points of the graph. So right here, it passes through point X and point A. So what would happen if point X got closer and closer to point A? Well, the secant line would start moving like this. It would become more negative. Well, that just means that it's getting closer to the tangent line, right? We're going to use this to find out the equation of the derivative.
A derivative is the slope of the tangent line at any point on a graph, and is usually found as an expression in terms of x for the entire graph.
So, right here, what did I do? Well, I denoted the difference between a and x is h right here. And I've also written out the equations. So let's take a look over here. Well, I've written down the definition of a derivative right here. So, f of x plus h. What is x plus h? Well, we've established here that h equals a minus x. So if we move over the x term, then x plus h equals a, right? So that means that this is just f of a. So the y value of a minus f of x, which is just obviously the y value of x. And then this is all over h. And as we've seen here, this is where it becomes important. H is equal to a minus x. So this minus this. So the distance between the two, that's what this is. So this should look kind of familiar because this is basically a slope formula, right? The y value of this term minus the y value of this term over the x value of this term minus the x value of this term. Except instead of using those terms, we just use the letter h to determine the distance between the two. So, Lieutenant, about this part right here, LIM stands for limit. And right here it says h arrow 0. So as h gets closer and closer or approaches 0, what is this expression? As h gets closer to 0, that just means that x is getting closer to a. Which means, as we've established before, the secant line is getting closer and closer to the tangent line. Well, that's exactly what we want, right?
Now, Lieutenant, let's do the easy part fast so we can stop the aliens. We need to plug in our original function into the limit where necessary. Notice how for the f of x plus h function, I plug in the original equation, but I just add an h to the x. But for the normal f of x function, I just plug in the original equation. In order to solve this limit, all we have to do is plug in 0 for h, but if we do this here, then we'll get 0 in the denominator. So first we have to do some algebra to this limit to get what we want. Here we just expand the x plus h squared term, and at the same time we distribute the negative 1 into the negative half x squared plus 3. Now we just multiply the x plus h by itself. Then we distribute the negative half into the product. Because the negative half x squared cancels with the positive half x squared, and the positive 3 cancels with the negative 3, the limit is simplified even more. Now we just factor an h term in the numerator. This is probably the most important step. Can you guess what happens next? That's right, we just cancel out the h terms in the numerator and the denominator, and we're left with a much easier expression to work with. And finally, after plugging in a 0 for h, we get a derivative of negative x.
Sir, I've just received a message that the alien base is about 4,000 miles away from ours. Well, if the base is 4,000 miles away from ours, well, since the origin is like about halfway in between, then that means that point A has an x value of about 2,000 miles. So if we plug in this 2,000 into this, well then we just get negative 2,000. Now what does all this mean? Well, that just means that the slope of the tangent line at point A is negative 2,000, which means that the instantaneous velocity is negative 2,000 at that point, which seems sufficient enough to blow up the entire base. Blow it up.